So today we're going to be looking at 10.3. It's the last lesson in this section and the last lesson that's going to count for grades on this quarter. And we're looking at composition and inverses of functions. So at the beginning for 10.1, we looked at rational exponents, then we looked at the exponential function and real exponents, and now we're going to look at composition and inverses of functions. So to start off, let's look at compositions. So compositions are when we take two functions and we evaluate them at a value of x and get a composite. So composite is f of g of x. It's red, f of g. So this is f of g of x. Okay, and so we're composing f with g to get a different value for x. And composition is the operation that produces that. So that symbolism here, this notation here has to do with composition, and then the value itself is the composite. And that's pretty much all there is to it. Now the way to find it is a little bit more complicated. So let's go ahead and look at an example. For 4a, we want to find the value of h of f of 32 when f of x is x over 2 and h of x is equal to square root x. Simplest way is to first just break it apart. So first let's figure out f of 32. Now notice I do not put an equal sign, okay? These are not equal. H of f of 32 is not the same as f of 32, so you need to not use equal signs here. Arrows are preferred. So f of 32, I'm going to plug in 32 for x in my equation for f of x. So I get 32 over 2, which is 16. I'm going to then take this 16 here, and I'm going to sub it in for the f of 32. So instead of being h of f of 32, this is now equal to h of 16. And so h of 16, we sub in 16 for x, we get square root of 16, which is 4. Okay? Let's look at b. H of f of 16 is what we're looking for this time. So again, first thing we're going to do is find f of 16. That is 16 over 2, which is 8. Then we want to then take h of f of 16 and sub in the value we got for f of 16, which was 8, in, and then solve. So we get square root of 8. So this is 2 root 2. Okay? Let's look at another one. Let's look at one where we don't get a value out. Let's say instead we get an equation. So in C, we want h of f of x. So let's remind ourselves f of x is equal to x over 2. So we're going to sub in x over 2 for f of x in our beginning composition. So we're looking at h of f of x, where f of x is x over 2. Then we're going to sub that in to our equation for h. Since we can't have a radical in the denominator, we're going to rationalize that up, and we get square root 2x over 2. Let's try one more of those. For d, we're looking at f of x. We're composing f with itself. So again, first remind yourselves what is f of x, which is x over 2. Sub that in for f of x in the original. So this is going to be f of x is what we're looking for, which is the same as f of x over 2. So we get x over 2 over 2, which is x over 4. Okay, and what might be beneficial for some of you, if you still struggle with those functions, is to replace f of x and h of x with f of something is equal to that something divided by 2, and h of something is equal to the square root of that something. And then replace whatever you put in the parentheses into the parentheses on the right side of the equation that you put on the left. Okay? Now you're probably wondering, well, why do I care about compositions, right? Because it doesn't really seem like it connects very well with a lot of math. And the reason why compositions are important is because that's how we define inverses. So f and g are inverses if and only if f of g of x is equal to x. So the composition of f with g is equal to x for all x's in the domain. And, okay, g of f of x is equal to x for all x's in the domain of f. So we have to have the composition of f with g and the composition of g with f be equal to x in order to have an inverse. The way to write an inverse is f to the negative 1, but it's not read as f to the negative 1. It's f inverse at x is what f inverse of x here means. That is f inverse at x, not f to the negative 1. Okay? And do not confuse inverses with reciprocals. They are completely different. Okay? An inverse is not a reciprocal, and a reciprocal is not an inverse. So let's start off by looking at finding inverses graphically. So instead of just going straight into solving for them, let's think about solving them graphically. Okay. Now, the two things we use are the horizontal line test and the line y equals x. The horizontal line test checks to see if a function is 1 to 1. Okay, and onto. Now, essentially what that means is that for every x value, we have one y value, and then for every x value, we would go to one singular y value. We don't have two x's going to the same y. Okay, so think of a parabola. A parabola would not have an inverse as is defined on all real numbers because you could have -2 and 2 both go to 4, right? So horizontal line test. So you're just going to take a horizontal line and move it along the graph to see if it crosses it more than once. And then y equals x is going to become important because the inverse of f is the reflection of its graph across y equals x. Okay, so if we don't know the equation, we don't have to worry. We can just draw y equals x and then reflect the graph we're given across that line. So let's go ahead and look at the graph of number 8. It looks like this, okay? So first thing I'm going to do is I'm going to draw y equals x so I can flip it pretty easily. Like so, okay? And so then I notice that I seem to cut the graph right through there. And so before I start figuring the inverse, I got to make sure the horizontal line test pass, right? So I'm going to take this pink color, and if I take, well, actually I can use one of these. So if I start here, if I put a horizontal line here, it passes through once, once. So we do have an inverse. Horizontal line test passes. Okay, so there's no failure there. Then we look at y equals x and we try to figure out how we're going to reflect it. So it's a reflection across this line. So if I take this tail end of my graph down here, reflect it across the axis, right at this point, it's going to go this direction. And my graph goes through -1, 0, and so my reflection has to go through 0, -1, like so, and then through 1, 0, and then back out. And so it looks like if I folded the paper, if I say I've cut my paper in half right here along this line, and then I folded it, my graphs would match up, hopefully almost exact, okay? Now this doesn't have to be an exact sketch. It can be as rough as you can get as long as it looks like an inverse, all right? So then let's look at 14. 14, they want us to find the inverse and then graph the inverse and the original function in the same coordinate system, all right? So for 14, there are a few steps. All right, if you look at your notes, the steps start with step 1 saying that we need to replace f of x with y. So we're going to do that. So y is equal to 12 over x. Step 2 is to then interchange the x's and y's. And step 3 is to solve for y. So we end up with x times y equals 12, y equals 12 over x. And finally, step 4 is to replace y with f inverse. Okay, so the inverse of our function 14 is just the inverse. Now, we need to graph this since we actually got an inverse out. And so the best way to graph this is to do a t-chart. So I'm going to pick values to the left of 0 and to the right of 0 and then plot. So for my f value, so I've got f and x, -1, 0, 1. -1 would be -12, 0 would be undefined, and 1 would be 12. So there's no graph at 0. Instead, we have a graph at -1, -12, which my graph doesn't go to, so let's say about here, and 1, 12, so this other direction. And then I'm going to pick a number like, let's say -12 and 12, so I get -1 and 1. So -12 is -1, and 12 is +1. So my graph has to go through those 2 points on each side, but not go through 0. So I have this one and this one. Do these slightly look familiar from first quarter? Okay. And so that's my graph here. Now, if you notice, I have the line y equals x already drawn on there, and that's because I want to show you what it looks like with the inverse. The inverse is supposed to be a reflection across y equals x, but if I reflect across y equals x, I just get the other side. So the inverse is actually the exact same graph as we saw when we solved for it. So the pink graph is also f inverse. So there's really no extra drawing on that one, which is nice. So let's try one where we might have to draw a little more. Okay, on 16, we're given g of x is equal to the cube root of 2x. So again, first step in finding the inverse is to replace your function name, g, with y. Interchange the x's and y's, or swap. And then solve for x. So we get x cubed equals 2y, y equals x cubed over 2. And then replace y with f inverse. Okay, so we've got our inverse now. So first thing we're going to try and do is graph the cube root of 2x. So again, first thing I'm going to do is I'm going to plot points. So we've got x and f, 1, 0, -1. If we plug in 1, we get the cube root of 2. If we plug in 0, we get 0. And if we plug in -1, we get the cube root of -2. Okay, let's try as well 4 and -4. Now we get the cube root of 8, which is 2, and the cube root of -8, which is -2. So we're going to plot this. So at 0, we've got 0. The cube root of 2 is less than 1, so I'm going to say about there. And then go in the negative direction. And then at 4, we're at 2. So 4, 2, and -4, -2. And then I'm going to graph. Okay. Now we're going to do another t-chart, this time for x in my inverse, using the same exact values. Okay. So this time I get 1/2, 0, -1/2. 4 cubed is 64 over 2 is 32, so that's a big number, and -4 would be -32. So those are big numbers. Let's try using a smaller one. How about 2 and -2? So 2 would be 8, so that's 4, and -2 would be -4. So I've got 0 again. 1 and 1/2, so 1 and 1/2. -1 and -1/2. So about there. And then 2 and 4. And -2, -4. And I'm going to graph. Okay. And if you look closely, they're pretty similar to each other. I think my pink one's a little too skinny, so I think if I edited this a little bit, let's say to about here. That looks a little closer. That's why I'm inverse. So the pink is F, so make sure you label with F, and then F inverse, y equals x. And so if you just look along y equals x, the lines are almost, they're pretty close to being sketches of each other and reflections, which is what we want. You can double check these graphs though with Desmos if you're not sure how you did it, if you did it correctly. But I do want to see a t-chart showing that you plotted points to get the answer, because you're not going to have Desmos on your test. Okay, last two. Let's look at 18. 18, we have g of x is equal to the absolute value of x. Okay, so on 15 through 21, there's not a guarantee that there's an inverse. In 11 and 13, they just told you to find the inverse, so you could assume there was one. But for 15 through 21, they say graph your equation first and then see if it has an inverse by using horizontal line test. So we're going to graph g of x first. So using a t-chart, okay, we've got x values and then g values. So if we plug in 1 for x, we get 1 for g, 0 for x, 0 for g, -1, and 1 for g again. So remember, absolute values always look like v's. So this is our graph. Okay. Next, we want to take the horizontal line test and see if it works here. And if we do a horizontal line test, right there, I automatically see the horizontal line test fails. So g is not 1 to 1. Therefore, g has no inverse. Okay? And I do want you to kind of be able to work with this reasoning on your own if I asked you to do it on the test. So I need to see that you did the horizontal line test, it failed, and therefore you know g has no inverse. You can't just guess. If you just guess and you get the right answer, you're still not going to get full points on that. Okay? So then let's look at 22. For 22, we have g of x equals 2x plus 3 to the 5th. So first thing we're going to do is we are going to graph g of x. So x and g. So when we plug in, let's plug in 0. That would end up being 3 to the 5th, which is 81 times 3, that's 243. So not a very nice number. If we plug in -3, we get 0 to the 5th, which is just 0. Okay? And let's say we plug in we really can't avoid any large numbers here, but we could probably do 1/2 isn't too bad. It's not great, but we'll do 1/2. So 1/2, we get 1 plus 3 inside the parentheses to the 5th. That's 4 to the 5th, which would be 64 times 16, which is 256 times 4, so that would be 1024, right? Yep, 1024. Okay, so these numbers are very, very large if you haven't gleaned onto that yet. So we're going to graph. So we plot 0, -3, and 0 is 0 and 243. So that's somewhere up in this area. And then at -3, we have a 0 here. So -3 is 0. And then at 1/2, we have 1024. So we're actually on this side much, much higher. Let's say we do -1/2 because I want to see the graph just a little bit better. Or even, no, let's do -1/2. So that would be 2 to the 5th, which is 32. So -1/2 is about there, and that's 32, which is somewhere down here in comparison. Okay, so we have a pretty high increasing graph here. So I'm going to take a wild guess and say it looks like this. Okay, so there's our graph. And so the next thing we need to do is we need to check to see if the horizontal line test passes here, which if we take our horizontal line and run it along, it does pass, so we're good. So horizontal line test passes, that means I have an inverse here. So now we're going to go back up to the equation at 22 and solve for the inverse using our steps. So first step, replacing that with a y, interchanging the x's and y's, and then solving for y. Okay, so, and then replacing y with f inverse. Okay, so now we have an f inverse. We are going to graph. And the best way really to do this, even though the numbers are so large, is again the t-chart, but we can also just reflect across the y equals x line, which I've drawn again here for us, okay? So I know that starting at this point, since we're crossing there, this rest of my graph is going to go this direction. I go through -3 on the x, so I have to go through -3 on the y. And then I'm going to increase very quickly past that -3. So I go through -3 and then increasing super fast right there. This is f inverse of x. Okay? And I didn't have to plug in any huge numbers on that one. I just reflected across the x-axis, which is much simpler than plugging in a whole bunch for t-chart. Okay? And again, like I said before, you can check with Desmos, but you do have to be comfortable working with this for your test. All right? So, your classwork is due Monday the 6th for C block and Tuesday the 7th for F block. Page 466, numbers 1 through 21 odd. Do not forget your test 15 is on Thursday and Friday, the 9th and 10th of March, and it will be the last test of the quarter.